Hi. Today we're going to be talking about the concept known as molar mass. Now, molar mass is basically the mass in grams of 1 mole of a substance. It can be any substance. Whatever 1 mole of that weighs in grams, that's the molar mass. Now, as we talked about before, since Avogadro's number was set by determining that the mass of any 1 mole of carbon-12 atoms equals exactly 12 grams, we're able to determine the molar masses of elements simply by changing the units of their average atomic masses from atomic mass units or unified atomic mass units to grams. Okay? So, again, if it's something like carbon, remember, you always want to read it out to 2 places past the decimal. So carbon has an atomic mass of 12.01 unified atomic mass units. Well, 1 mole of carbon atoms would weigh 12.01 grams. So whatever it is in use, it is now that in grams. Also, since the primary purpose of molar mass is to be used in chemical conversions, it is most useful to express it as an equality. Instead of using units of like grams per mole, I always want you to write molar mass like this. 1 mole of the substance is equal to whatever number of grams it is. In this case, 1 mole of iron is equal to 55.85 grams of iron. Now, you could write it the other way. You could write 55.85 grams of iron is equal to 1 mole of iron. It doesn't matter, as long as you always write it as an equality. All right? And don't forget to always calculate the molar mass out to the second place past the decimal. Now, for compounds, as you guys know, is a collection of atoms that are chemically bound together. All right? Either with ionic bonds or covalent bonds. And when you look at the chemical formula, that tells you how many of each atom there are. So for example, in methane here, CH4, there's 1 carbon of atom and 4 hydrogen atoms. 1 atom of carbon and 4 atoms of hydrogen. If you were to figure out the molar mass, it's very simple. You simply sum up the masses of the component atoms. All right? Very, very easy. I'm going to show you how to do that in just a minute. Okay? And this is the same process as for determining molecular mass, but the units are in grams, not in unified atomic mass units. All right, so remember, the molecular mass is the mass of atomic mass units of 1 molecule of a substance. Now, so I'm going to show you the molar mass example of CH4. Now, the process is the same for each compound. First of all, you list out each element that is present. We have carbon and we have hydrogen. Next, we indicate by looking at the subscripts how many of each atom, how many atoms of each substance there is. Since there's no subscript there, we only have 1 carbon, but because of that 4, we have 4 hydrogens. We then multiply each of those numbers by the average atomic mass of each element as found on the periodic table. When we look on the periodic table, we see that carbon has an average atomic mass of 12.011. Remember, when you read the average atomic masses from the periodic table, you always round off to 2 places past the decimal. So carbon rounds off to 12.01, and hydrogen rounds off to 1.01. That's 7 changing the 0 into a 1. So that's 1.01. We multiply them out, we get 12.01 there. 4 times that is 4.04. And then the last step is simply to add it up. Here we have 5061. So the molar mass would be considered 16.05. The format that you should always write molar mass out into is as an equality. So we say 1 mole of methane is equal to 16.05 grams of methane, because molar mass is equal to the number of grams of a substance equal to 1 mole of that substance. But also, if it is ions, remember, they have the same masses as the atoms from which they are formed. Therefore, determining the molar masses of ionic compounds is done exactly the same way as for molecular compounds. Doesn't matter if it has electrons or not, they all weigh the same. All right, and here's an example of an ionic compound in the case of aluminum sulfate. Now the next example we're going to look at is a bit more complicated. It is aluminum sulfite, an ionic compound. So we're going to look at this. Again, we list out each substance presence. We have aluminum, we have sulfur, and we have oxygen. Now, according to the subscripts, we have 2 aluminums. Since this sulfur is inside parentheses, this 3 distributes into each of the things inside. So we have 3 sulfurs and 3 times 3, 9 oxygens. Again, we multiply each of those numbers by by the average atomic mass of each substance. For aluminum, it is 26.98. For sulfur, it's 32.07. And for oxygen, this rounds off to 16.00. So aluminum is 26.98, sulfur is 32.07, and oxygen is 16. We multiply those numbers out. This time the calculator would come in handy. We have 26.98 times 2. We have 53.96. 32.07 times 3 equals 96.21. And 9 times 16 equals 144.00. And then we add up all 3 of those numbers. So 96.21 plus 53.96 plus 144. I get 294.17. And again, I want to write that number out as an equality. So 1 mole of aluminum sulfite is equal to 294.17 grams of aluminum sulfite. And there's my answer. Thank you very much. I hope you found this to be useful.